All right, so this is the technology behind GridPoint. But before I get into the technology, let's do a little overview of what GridPoint actually does as a business. And so GridPoint's customers operate physical commercial spaces. So you could think of these folks like the restaurants and the retailers of the world here. And one of the problems that they have is managing their energy expenses. So it can take a good chunk of their money to heat and cool these commercial spaces. And the balancing act here is, on one hand, trying to optimize that savings, that cost, but on the other hand, not going too far to where the people patroning your building feel uncomfortable and don't want to be there anymore, right? So finding the line of that right balance. And there's another side of this for demand response. So the energy providers also offer incentives during certain times of the day where if these customers can curtail their energy usage, they'll get a bit of savings on top of that as well. They'll get an incentive to do that. So the way that GridPoint goes about this is with a couple pieces of technology that we're able to install in these sites. So the device on the far left-hand side of the screen here is our energy management controller. And this is like the brains of a site. This is the controller that runs one of those locations. And then this talks to several other devices around the site as well. So next to it is one of the thermostats. And these are the devices that are controlling each one of those HVAC zones, just like you would have a thermostat in your house, except it has a little more complexity behind it to run in these commercial scenarios. So these thermostats are all networked together and have to talk back to that controller. And they're also pushing that data up to the cloud. So on the right-hand side of the screen here, this is an example of our cloud services dashboard that's available to these customers. And from here, they can monitor those locations. They can also control those locations, so you can increase and decrease the temperature of each zone and things like that. And they're also able to look at their energy savings as well, so they can see how much energy their site has used, as well as savings numbers on top of that. So this is cool, and GridPoint's been operating this type of system for a long time now. But the current platform has been getting a bit long in the tooth, and we're at that point where it's time for a platform upgrade. And one of the pain points that we've been running into around this is the issue of reliability, making sure these systems are doing what they're supposed to be doing when they're supposed to be doing them, and that they can be upgraded since this is cloud-connected hardware and software, making sure that we can upgrade these systems regularly as well. And so that's one of the places where Nerves comes into play. Nerves might sound like a new technology. Some of you might not have heard of Nerves. A handful of you who are the regulars here have definitely heard of Nerves. It's a way to run Elixir and the Beam VM on top of an embedded system. And Elixir might sound pretty new. However, the Beam VM and those underlying workings there are something that was really developed by Ericsson back in the 80s to run on the telephone switching networks. So really robust set of tooling there that they provide, and they also provide a standard library out of the box called OTP. So not only do you get a robust virtual machine, but you're also getting a library that helps develop those types of systems as well. So this seemed like a really good fit for that new hardware that we're developing. If you want to know more about the high-level overview of this, Mike Ratliff, our CTO, has talked about this in another presentation at the Meetup, so feel free to check that out. And I'm Alex. I'm one of the tech leads at GridPoint, and so I run the team that is building out the new controller and retrofitting the current one. And I have a bit of a interesting background. So I've spent part of my time developing control systems. And I've spent another part of my professional development career building web applications. And really within the last couple of years, I've been able to blend both of those together into crossing the stack and really building entire connected systems, or IoT is another one of the words for it, within those last few years. And for about the last decade, I've also been doing this as a consultant. And so I've had a pretty broad perspective on a lot of different ways that customers have gone about building and installing products, and seen a lot of different industries and a lot of different ways of doing things. And that's been a really nice perspective to have across this ecosystem. So let's go ahead and dive into the controller. So like you saw earlier, this is the EC2K controller. This is one that GridPoint has been selling and installing for quite a while. As part of this platform upgrade, this is something that needed a bit of a change. And so because we've deployed so many of these, we can't just go bring them back in the field. So we can't RMA these. And it's also too cost prohibitive to go out and send an installer out to do updates for every single one of the sites that we have installed. So one of the challenges in doing this platform update is we need to be able to get new firmware onto these controllers, Nerves-based firmware, over the air. And so that's a bit of a catch to some of you who have been through this. Yeah, you might be clinging onto your seat a little bit at this point. But we managed to do this in about 5 months. And I'll walk you through the process of what this looked like as well. So a little bit of what this system looks like end to end. We have on the left side of this some of those devices that live on site that I mentioned earlier. So we have the thermostats. We have another device called a main load meter, which hooks up to the electrical panel in one of these buildings and monitors the energy flowing in and out of the building. And if you're wondering, wait a second, why out of the building? Well, some of these buildings have solar installed, and so they're not always consuming from the grid. They're also producing to the grid as well. Those talk over ModBus, which in this case is a wired connection. It's RS-485 over a twisted pair cable. And all of those are wired up into that EC2K controller. And now that controller happens to be running Nerves. That controller is then aggregating and pushing that data up through a WebSocket, and that's talking to a Phoenix server on the other side. So this is another part of the system that's running Elixir. That Phoenix server is storing its data in a timescale database. This is a Postgres extension that helps with time series data. And time series data is one of those really important things to be able to optimize around in a connected system because it works differently than your traditional relational data does. So this is something where you need to bucket things like telemetry data points. How hot or cold is it right now? Those get bucketed by time. And this is a type of system that can help with that. Then on the far side, we have the desktop application. So we have the web app that happens to be in live view. And that's what you saw earlier there. And we also have a mobile application that our installation crew can use so that they don't have to have computers on site and they can commission the system right from their phones. Then at the bottom of this, I have Nerves Hub on here as well. So we're still running Nerves Hub 1.0. For those of you that know that 2.0 is out, we're not quite on that yet. Still a little too new there. But this is the mechanism that's pushing those OTA updates out to the controllers that we have in the field, the new Nerves-based controllers. And we're able to console into them and do maintenance over Nerves Hub as well. And so I mentioned we've got the retrofit going on. So how do you retrofit an existing system, an existing piece of hardware into being able to run Nerves and being able to run that Elixir application? And so if you're coming from the website, you're probably familiar with the top two parts of this stack. So the first one is that Elixir firmware application, and the next one is the Beam VM that it runs on top of. Unfortunately, that has very little to do with the retrofit portion of this. We're down in the other two layers that may be a little less familiar and honestly probably scary to a good chunk of the folks out there who dive into this. This is honestly a pretty complicated part of the system. But that's the part that involves embedded Linux. And so all the drivers you need and the configuration you need there and the device trees that need to be set up, basically like the description of the hardware and what needs to run it. and then also the bootloader. So the thing that gets you the system booting up into embedded Linux off of whichever device it's supposed to be able to boot from. And so that's where the big chunk of the work was in the retrofit, was being able to get that hardware to support Nerves and then be able to drop that new application on top of that. So this bottom layer, you're spending a lot of time in build root at this point. And build root is really it's tooling out there to be able to stand up a custom embedded Linux system. And this happens to be part of the Nerves framework. It relies a lot on build root. So if part of this sounds a little intimidating or it sounds complex, I won't lie, it's pretty complex. It took a while to do this. However, it's not just Nerves that you need to look out for this. Build root has a ton of documentation and a ton of resources on how to be able to do this kind of thing. And that's really the foundation of where this is at. So the system that we happen to be running on is the SAM A5T27 processor. And if you've looked around at the official Nerve systems before, this isn't one that's in the list. There's a handful of official Nerve systems that exist. And if you're going off of that, it doesn't necessarily mean that you can't do Nerves. It just means there might be a little more work to doing it. And so this was part of being able to stand up that custom Nerve system for this controller. And we did get a little bit lucky on this one. So I mentioned consulting experience, and there was a project that I've worked on in the past where we actually did have to go build a system on this processor. And the system for this did end up getting open sourced, which was great. It just happened to fall out of maintenance, pretty far out of date out of maintenance. So we were able to pick this back up, bring it back up to speed, and now we've got a new Nerve system that works for this Microchip evaluation kit that happens to run the same processor that we have as a baseline. And then from there, it was redoing kind of that whole description layer of what hardware is set up to be able to get that off of how the dev kit is set up and onto how that EC2K controller is set up. And that part was a pretty good chunk of work. By the way, if for anyone who is looking at doing a commercial project, like I said, this is up as open source right now as well. So Microchip is one of those options that you have as a processor and a Nerve system available if you're looking to build out your own commercial product there. So then another issue we had is, how do you end up doing data storage on this embedded system? And on one end of the spectrum, the simplest end of the spectrum, you've got flat files. We could store all of our settings in the file system, in their own files, and that would be one way to do it. On the other side of the spectrum, you could go as far as running a relational database on the embedded system. And probably the best way to do that with the resource constraints on there would be to look at something like SQLite. But we decided to do something in the middle of that. So we want something a little better than files, but a little lighter weight than even SQLite, even though Lite's in the name. And so we pulled CubDB off the shelf. This is part of the Elixir ecosystem. And this is a key value storage database, NoSQL database. And for those of you on the website, this feels a lot like using Redis. And so it gives us, number one, a unified space to be able to do key value access. It's really easy to work with. From the embedded side of things, I mentioned that robustness and resiliency was a problem earlier, a pain point that we wanted to solve for. CubDB has that in mind and is great for the embedded use case because the way that it stores its data is designed around being able to survive power failures and other types of faults like that you might encounter in an embedded system. So you don't have to worry about losing all your data or corrupting your database if you have somebody pull the power on your controller. Another piece of technology that we were able to use off the shelf, which really helped speed this along, is ModBux. And so I mentioned the devices talk to the controller. over ModBus and over RS-45. And so this is one of the libraries that that enabled that controller to be able to talk ModBus without having to write that from scratch. So this was a library produced by Valiant, and Alday maintains this. He might actually be on the call right now, hopefully. This is something that's great to check out. If you have to interact with ModBus, this library can really jumpstart your project if you're doing that in Elixir. So then there was some more custom stuff we had to do as well. And Speck is one of the libraries that I've written for input validation and also to help with protocol documentation. And that ended up being one of the things that made sense to work into this controller. And so just to break down what's going on here, kind of in that diagram on the right-hand side, you've got some kind of external input. On the web side, this is probably coming from a user typing into a form. In the case of an embedded controller, this is like the server sending messages to the controller. And so we don't want to blindly trust those messages coming in. We want to make sure there's some kind of sanity check over that information. So I explicitly call out a validation layer here. In an MVC style framework, you don't necessarily have an explicit validation layer in MVC, but you can make one if you want to. And if you're doing that in the Elixir space, especially on the website, you're probably using Ecto, and that's kind of taking care of that layer for you, just more behind the scenes. So the goal is get through that validation layer, be able to either pass or fail, okay or error that message coming in. And if it's not successful, you want to kick that back up to the caller who sent it to you and say, hey, I can't process this message. And if it is okay, then you want to send it off to your business logic so that your system can go do that processing and then probably send it off to storage somewhere. And so the idea around Speck, for the folks of you on the website, you're probably asking, well, why not use Ecto? It already exists. And one of the problems with Ecto in this case, I've used Ecto on embedded projects before. You can make it work. One, you saw we're using CubDB, so we're not using a relational database. So we can't wire Ecto into the database. And now some of you are still probably saying, well, use embedded schemas. It doesn't matter if you're using a relational database or not. And we did try that as well. I've used embedded schemas on other embedded projects before. In this particular case, and one of the things that's felt like a little bit of friction there is still the Ecto feel really feels like you're working with a relational database, even if you aren't. So we wanted to break away from that a little bit. And there are some documentation advantages that this library is able to give us as well. So one of the ways that this looks is it still kind of looks like Ecto. It's probably not too foreign, from building an Ecto schema. But it was really about making something that's a very thin, light validation layer, and then it does its job and gets out of the way. And a spec that was also easy to understand for folks across the stack. So we also work with other hardware developers. My team works with a web team. We have a lot of different eyes that have to be on this code. And so to not have something that was Elixir specific in its concepts can make this easier to understand for other people across the stack. So on the left-hand side here, you see what one of these specs can look like. This one didn't come from GridPoint. This is from the example documentation. And then over on the bottom right here, you see how you can actually use that. So you call the validate function. You pass in your struct to it that you want to validate against. You pass your params in. This probably feels familiar to most of you right now. And then you can check either, did you get an OK message? And if you did, you can go send that struct on to your business logic that needs to process this. So in this case, we want to create a device. And if you had any errors that came back, you can process those errors. You can kick them back up to the caller or whatever you need to do. So another library that was really handy that I ended up making and became really handy to use in this type of system is Resolve. And this is a way to be able to do dependency injection in Elixir, and especially for embedded systems. So you can use this in the web if you want to. It still works there. But there are some scenarios that are specific to embedded systems that this really helps with as well. And so one of those is anytime you're working with an embedded system, you have the actual hardware that you want to run that code on, that you want to run that firmware on. But you also need to deal with unit testing that code. And you're most likely not unit testing on your hardware. You're doing that on a computer. You're doing it off in the cloud, in CI somewhere. You don't have access to the hardware when you're doing that, but you still want to be able to run unit tests. And so dependency injection is a great solution to be able to do that. And don't get me wrong, you don't have to use this library to do dependency injection in Elixir. There are a bunch of different ways to do it. But this one really has that type of pattern in mind. There are a couple other cases that you might want to be able to do as well when you're developing an embedded system. And one of those, like the unit tests, so like the unit tests don't need the hardware, those can run on your host machine. Well, what happens if you want to run your firmware on your host machine to be able to have a faster development cycle? Or you don't want to have to spend the money to equip your team all with those embedded devices, or in our case, like we have 5 different teams basically working on this whole platform. So it makes sense for our firmware team to have these devices, but if we gave every single person in the company a device, then we're, it's a whole lot of hardware to pay for and a whole lot of hardware to track. So, but those folks still need to be able to test against stuff and be able to have an idea of what the system is doing. So your host there, your computer, can be another type of target that you're running your firmware on. And dependency injection, and especially how Resolve does it, is something that can help out there. And then the other place is, what happens when you have multiple hardware targets that you need to support? And it's less friction and a lot simpler to have one piece of firmware that can run on 2 different types of devices. One good example of that, thankfully GridPoint isn't facing this, but one example from the recent past here was the chip shortage. And so what happens when you've got your firmware that you've already developed and shipped, and then you can't get that chip anymore? You have to get a new chip. Things work slightly differently on that hardware, but overall you want roughly the same functionality of your system. And that's another great place to use dependency injection there. So you can have the same behavior, but different implementations of that behavior. And if you look at the diagram on the right-hand side of the screen here, this will tie into the next slide. So the concept behind this is you can have a caller, in this case, getting a serial number. It's wanting to get that from a module. You're going to have that function in a module. And so the question here is, which module should go in that place for this particular platform? Should it call off to cryptography hardware because the serial number is on a physical chip that you need to get that number off of? Should you call into the file system because another piece of your hardware doesn't have that crypto chip available, and so you need to be able to get that serial number from file storage? Or are you in your unit tests and you just want to make up that serial number because you don't have the hardware available and you're just trying to see if something else in the system passes or fails? So here's some code examples of what that looks like. On the top here, there's a couple different ways that you can integrate Resolve. This is using that proxy module pattern that you saw in the diagram earlier. So this is kind of like an empty or like a skeleton module where you can define some command that you want to inject or that you want to have injectable. You wrap that in Resolve. You can pass your module name into it. Really doesn't matter what you pass into it there. You're just saying, I want to do some type of function call on some type of module. And then there's 2 ways you can go about doing this. So on the bottom left, we've got a compile time configuration where you can put this in your project's config file and say, I want to map this original module. Whenever this original module gets called, pass those calls over to this injected module. And at the top here, the compile flag is set. So these mappings get baked into your firmware compile time, so you don't have to worry about runtime overhead of what that resolution looks like. For things like development, if you're trying to be able to play around with different implementations of a module, or you're trying to do, you want to copy paste code right into IEX and see changes, or your unit testing, where in one test you want to have one type of behavior, and another test you might want to have another type of behavior right after it. You can do runtime injection, which is on the bottom right here. And one of the other cool things that you have about this pattern is, especially for like unit tests, you probably don't want to create a module, a named module for every specific unit test where you want to use this. So this will let you inline that module code right inside the resolve.inject call there, and it automatically creates a module for you behind the scenes and names it some random thing and throws it away when it's done. So you don't have to do that module management yourself. You can inline this right into your tests. So another major part of this system was dealing with the UI. It's got a touch screen on it. The old platform has an interface that does get used in the field. It's part of the installation process as well, so it gives installers feedback on what the system is doing and lets them do some network configuration if they can't configure it from the cloud yet. And so we've got to take a diagram out of Figma from our graphic designers on the left-hand side here, and we got to get that design running on the controller somehow. And so if you're coming from an Elixir background, if you're coming from the ecosystem, you're probably screaming already, hey, use Scenic for that. And great idea, except. So we were using Scenic for this, and out of the box, the Scenic provides Scenic driver local. And that happened to be based on GLFW, which is how it was rendering things under the hood. That's a rendering library, basically. And we put this onto that controller and had absolutely terrible performance. It was rendering, it felt like an e-ink display. So it was rendering one frame about every 30 or 40 seconds. It was not a usable system. So that was a bit of a problem, because what were we going to do about that? There were a couple options, but what we really didn't want to do was have to go to another type of UI framework that was outside of the Elixir ecosystem if we didn't have to. So we ended up reaching out to the Scenic open source maintainers, and Chris had a really interesting idea of, hey, what if you switch out GLFW for Cairo, which is a different graphics rendering library? And so we tried that, and it was just night and day. I mean, it took a long time to do. It took about a month or so, if I remember correctly. But it was night and day performance. This made the system totally usable. And this was just amazing. And so a lot of this work was done by John Ringel. You've probably seen him at the Meetup here a couple times, for those of you who frequent the Meetup. He's the one on the right-hand side of the picture here. And he put a ton of work into this. He really led the effort on this. And the performance on this is absolutely amazing. And he was also able to open source this and push the changes back up to Scenic Driver Local. So the community has access to this as well. So if you've been working with Scenic and you've experienced performance issues with it on your platform, or you haven't been able to get GLFW to render on your platform or stuff like that, go take a look at it again. Go try out Scenic Driver Local again. Try out the Cairo changes on your project. This might really, really help what you're working on. So big thanks to John for that one. I'm also working on twisting his arm into giving a more in-depth presentation on this, so hopefully you all will get that too. So we've talked about building the product. Now, what about building the team? And so one of the ways that traditional development has been working is languages kind of get siloed into certain domains. So back end working on Elixir, front end working on JavaScript, firmware working in C or C++. one of the trends that you've probably seen in the Elixir community, if you've been keeping up with Elixir, is that Elixir is working its way into more of those slices of the stack. So we've always had a way to render out web pages to front end, but now with live view, it's real time. It's real time updates to the front end. Basically, a pretty big competitor to JavaScript at this point of what you can do natively in Elixir versus what you can do, or sorry, natively in JavaScript versus what you can do with Elixir on the front end with live view in your system. Nerves is the same type of thing with the firmware side. I'll say, I've said this before in other talks, you're never going to completely get away from C. It's in the Linux kernel. Nerves is built on the Linux kernel. It's something you're going to have to work with. But this really Nerves really gives you a way to put Elixir into a very big slice of that domain. And so you start seeing the shift to something more on the right-hand side of the screen here, where Elixir starts turning into this language that can unify all the parts of your system together. And theoretically, the cool thing about this is that you can transfer engineers between different parts of the system easier as well, because now you don't have to completely retrain everybody on a completely new language and a completely new piece of the stack. Hopefully there's a thread that helps tie this stuff together. And this isn't necessarily a new idea. I'm not the only one who's thought of this, but I did happen to publish an article on largest site on Underjord a couple of years ago about this. And other people have definitely had a similar idea since. So cool, this is amazing and it works wonderful and all that, right? Well, there is a problem to it. And it's something that I've been seeing the more that I've worked with other folks from other disciplines and other skill sets and backgrounds and all that. And just to be honest, the domain knowledge is a stumbling point in this. When you're going from firmware to web or vice versa, those two disciplines are a little bit like oil and water. There's not as much that, well, they're two completely different things to keep in your head. And so only having the programming language tie its way through the stack can be a good start, but it's not all of it. There is more to that picture that you need to be thinking about. And this is definitely something that I've seen, especially the web folks in the community who speak up online for help and stuff like that. That domain knowledge can definitely be a stumbling block. So that is something I just want to call out. Just because you switch the programming language doesn't mean it's still going to be an easy transition over to the other side. But one of the things that we are doing to help with that is cross-training. And so the place we started is cross-training our existing Elixir C++ developers. Did I say Elixir C++ developers? We were cross-training our C++ developers into Elixir, and this is the team that I run. And so this was starting with folks that have that base level domain knowledge, and we're putting a new programming language knowledge on top of that. And Ben has shared his experience on this. He's one of the guys on my team, and he's done a talk about this at the Meetup as well. So I'd say if you want to hear more about the experience on that, definitely go check out his presentation. I think he's done a really good job of a overview and the experience going through that. But that's one of the approaches to it. So then the other side of this coin is, how do you cross-train from the web development side to the embedded side? And this is something we're working on right now. It's not something I'm going to speak too much to in this presentation yet, because there's a lot to it, and honestly, we're not all the way through it as a company, and I'm still formulating my own personal ideas around this as well. But this is definitely something I would like to speak about at some point. So I'll say this is in the works. So then we come to the edge, and this is a new controller that GridPoint is developing. So I mentioned the EC2K that's undergone a retrofit. This one is greenfield. This one is brand new, also being built on Nerves. But the question would be, hey, if we just retrofitted something, why do we need a new controller? And the answer is wires, or more specifically, to get rid of the wires. So we send out installers to go install these products. They are a third party. They have their own cost associated with them. And it can cost a lot of money to have somebody go out and pull cables. And so the idea here is by going wireless, we can help speed up that installation time and be able to get these systems installed quicker. And so to revisit that architecture diagram, like what does this actually look like? So on the right-hand side, we start turning those sensors into a couple different types of sensors with a couple different ways that they work. So sensors that can be low powered, like zone sensors, for example, things that just need to read temperature or humidity. Basically, they need to wake up, grab a reading, send it off, and go back to sleep. For those, we're using LoRa. And here we're not using LoRaWAN, we're using LoRa point-to-point. It's a lot lighter weight. It's able to talk directly to the controller. But that's a long-range, low-powered wireless technology that we're able to put in place there to remove a lot of those ModBus connections. The other thing we're looking at is we have high-powered devices that have to be always on. They're controlling things like the HVAC units. They have screens on them where they need to be responsive if a user touches them or wants to input something on them. And those are devices like our thermostats. So for those, we're looking at using Wi-Fi as that higher powered network to be able to connect those devices together. And for this, we're not using the customer's Wi-Fi. That's pretty flaky. So we're having the edge controller be able to broadcast its own private network and adopt those devices. And then on the controller itself, that's traditionally connected via Ethernet, and it is still going to be connected via Ethernet primarily. But what happens when that cable gets cut or somebody accidentally unplugs it, as maintenance is happening or something like that? Or what happens when IT comes in and they change their networking rules and accidentally remove some of the access control? They accidentally block the controller from being able to connect to the internet. Well, because these are the systems that are responsible for managing the climate control of a building, we don't want the system to go completely down. So this also has a cellular modem that's built into it that it's able to use as a failover to be able to connect back up to the server in those cases. And these are going into manufacturing right now, so some cool stuff that we're currently working on. On the left-hand side, this is what the controller looks like, and it has 1 million antennas for all the millions of wireless technology you just heard me talk about. And on the right-hand side here is what the thermostat looks like for that. So that being said, let me open it up here to some questions.
I asked one a bit earlier, but what about Cairo is so much better than GLFW in this use case?
Yeah, so I'm going to tee John up for this one. But from the UX standpoint, it worked is the short answer. So we were actually able to get frame rates where it was a usable touchscreen. On GLFW, 1 frame per 30 seconds. You can't have somebody on site there pressing a button and then sitting back and waiting for that to work. John, do you want to go into that any more from the technical side of that?
Yeah, sure. So on the embedded side, it was not only that it took 30 seconds per frame to render, but sometimes we would even get out of memory errors and things like that, and it wasn't stable at all. So with the Cairo, basically Cairo will basically render the image into memory, and then I basically had that image basically written directly to the frame buffer device on Linux that Linux provides on /dev/fb0, and just memory map that device in and copy the image from Cairo onto that, and that just the performance of that was just incredible, and I was able to get good results on our embedded device. And then I took that a step further and also had Cairo also work with GTK, so you could run it on your host as well. So it's the same library and basically completely being able to replace what you would run on the back end for your host and for your target. And what we're doing on a target is universal. I've had it work successfully on an RPi 4, RPi 3. I've got a black BeagleBone black that I'm about to test out, make sure that it works on that. And so it's pretty cool. So.
And you said initially GLFW gave you like 1 frame per 30 seconds. What is the frame rate roughly now?
I'm not sure what the frame rate is, but it'll render the cursor seamlessly. The mouse will move around just fine. It feels like you're just on your own computer with a mouse moving around, and each time it's doing that, it's rendering the whole frame. So I don't know the numbers for the frame rate, but it's very, very responsive.
Hey, Alex, this is Ian. I joined late. I do have a question. Sorry if you went over it. Those remote sensors that are able to go to sleep and then wake up and then broadcast their data, are those Nerves devices? And if so, what kind are they?
Yeah, good question. Those are not Nerves devices because they have to be so low powered and even more resource constrained. So we keep the Nerves device as the controller of that system because that's really what makes the good bridge between the cloud and those other devices. Those other devices are running C. They're in a bit of an in-between state right now. There's some C that's if I remember, so I'll also say this is also from another team. So I'm speaking slightly out of my area right now, but we integrate with this stuff. Those sensors are implemented with some of Microchip's tooling right now because it's more parts in their series. I forget which microcontroller they're using for that. And oh no, I do remember. It's the R37 series, Microchip's R37, if I remember right. And then on the other side, we have one of those chips on that new gateway as well to operate as the LoRa gateway portion. And we're using Zephyr RTOS for that right now.
Are you saying that the one that receives the sensor data is running a separate chip as well to receive the LoRa data?
Same family of processor, different firmware.
Got it. Okay. Thanks.
Yeah, you're welcome. Yeah.
So it's great to see kind of from the start to end how you ended up. Maybe you could talk a little bit about some of the things you decided not to do, whether in between Nerves versus this because of this reason, or Scenic because of this reason and not HTML, or anything that just springs to mind. I don't really have any specific questions, but it's always interesting just to hear all the reasoning behind those decisions sometimes.
Man, that's a great question. I think in honesty, we had like 5 months to launch that controller, so it wasn't a whole lot of what shouldn't we do. It's what's going to work and what's the fastest path forward to do this. So we didn't have a whole lot of like sitting around stroking our gray beards about philosophically what technology is going to work the best or not. We did have a few technical evaluations, but it was they were faster than what you might experience at a handful of places, and it was really for validation of here's the idea we think that's going to work, or here's the technology we think that's going to work, and let's get to will it work, yes or no, as quick as we can. And if we got a yes, we didn't really go back and second guess it. We moved forward with it because we needed to.
What does your process look like to release from code to going on device?
As lightweight and quick as we can make it right now. But that being said, so I guess to give you a little bit of what that looks like is a release branch that we make tags off of, and that's how we're able to cut firmware releases. The web side of things is something that we have to integrate with, and sometimes there can be release dependencies around that. So it's coordinating with. We actually have four web teams. I run the Nerves firmware team, and then we actually have another embedded microcontroller team that's yet another team. So we have a lot of folks working together. So more so we have to coordinate on the website, making sure things are going to line up there. Every now and then we also do have to coordinate the other direction and make sure that our stuff's going to work with the microcontroller firmware coming out. But usually that dependency happens to be easier. That's more of like, hey, they've got a new feature that's going in or some new registers we can use or something like that. And we're able to pull that version of their firmware in. That rolls into our version of firmware, and then that kind of rolls up to the website. So, and then release cadence is every 3 weeks.
Would you say it's something like you have a commit that's tagged, that goes through CI, you build an image, you put that on some QA devices, that's verified, and then that's pushed out to 1 or 2 devices, and then the rest of everybody kind of thing?
Yeah, except for the last part, we're still small enough in deployment that the pushes go out to everybody. But yes, and as part of the QA process, it's end-to-end QA. So we have those QA engineers testing the firmware against the web release as well. So that might be something that's a little different from how some folks do things. But yeah, it goes through that entire process. If any fixes need to happen on either side, then those go in the respective code base, and then we say, hey, it's time to deploy, and then the firmware goes out, and then the server code goes out.
Any one place in your mind of those that causes more bugs, or you miss more bugs or anything, anecdotally?
I don't have an answer jumping out at the top of my mind for that now.
Me either, just curious.
Yeah, for me, like the product development, not just at GridPoint, but just kind of across the board, in my mind, and just style of projects that have been run is, obviously you've got the whole process set up so that you don't want to have bugs, but in the nature of people writing software, bugs are just going to happen, right? People make mistakes. That's just the nature of things. So I look at it more of turnaround time on that. How fast can we fix something when we know there's an issue? And so that's one of those nice points about having QA in the loop. So when they find something, fixing it quickly there. The other thing that's really nice with having a tool like Nerves Hub in play is if something happens in production, being able to use that to get into a system that's having an issue, figuring out what's wrong with it. And I mentioned that these sites get installed by professional installers. And so we can have code re-released while that firmware re-released while that installer is still on site. So they don't have to return to site to have an issue fixed. So that's one of the big things that I look at is what's the response time on that? And at least in my opinion, we're pretty quick on this one.
One final question, and then I'll shut up. How do your devices get into Nerves Hub? Do you, like at the manufacturer, you put them in, or is there like a manual provisioning step, or is it like just in time?
That's a great question. So we're still so new on the conversion of this that honestly, the manufacturing process is not completely set up yet. I actually don't see Ben on the call to make fun of him. Ben is kind of the provisioning process right now. So one of the ways that that we planned this out, just knowing how our demand planning was working, all that kind of stuff, was we could defer that process for a little bit, that manufacturing process, because these controllers came from an existing product line off the manufacturing line. And so right now we're able to grab them off the shelf in the warehouse in batches. And so we'll convert, like 50 of them or 100 of them over to Nerves in one batch, and we'll put them back on the shelf. And so we're able to do the Nerves Hub provisioning process and all that during that time. This is still at a small enough scale for the new product that we can do that, but you're leading into, no, we can't get away from that forever. And coming up at the beginning of next year here, that's exactly one of the problems that we're going to have to solve. And so it's going to be integrating that process, into the manufacturing process and getting those devices registered as part of that process. Let's see, I got another one in the chat here. So have you ever had a major issue rolling out a new change? And if so, how does your team go about fixing many physically remote devices, especially if they lose internet connectivity? That's a great one. Let me put Abelino on the spot if he's around. He and I do a lot of this work, but he really leads this work at this point.
So luckily we haven't caused any detrimental issues where we lose connectivity, especially to Nerves Hub. Causing a bug that causes Nerves Hub link or the link up to Nerves Hub to completely go down will basically mean that we're blind and we need to RMA the device. We haven't caused any of those crazy issues, but the issues that we have that have or bugs that have made themselves their way into the firmware, we've been able to easily overcome them through simple Nerves Hub firmware updates through Nerves Hub, which has been great. There has been issues. There has been times where we've needed to manually fix state in devices, and that can definitely get a little hairy, and it's a very slippery slope and can lead to bricking a device if one is not careful and either enters incorrect configuration or bad data into the IX console. I personally have a very strict process for that, and will triple test anything that I do on a remote device on a local device, and that's just a practice that I've followed for so many years in order to combat issues like that.
Yeah, we keep two people around during those types of cases too, so we have two eyes on that process while it's happening. So if sometimes when you're doing these types of changes, late at night when these sites are offline, after hours, so you're not interrupting anybody. One person's, brain might not be all there at that point, and you might not recognize it. So just having that second person, looking over what's going on and saying, "Hey, wait, did you mean to type this? Should we run this thing afterwards?" That can be pretty nice. The other thing that I could add to that too, because Abelino has probably repressed these memories by this point. We did have one site where we did lose connectivity. If I remember right, I don't think it was on our end. I think the controller was having issues, and then the customer went over and ended up unplugging it, so we couldn't get to it anymore to update it remotely. But in that case, we were able to send an installer back out. And yes, there is a little bit of a cost associated with that, but we were able to send an installer back out, get things plugged back in, and then do an update there.
One question regarding the Nerves controller that collects the data from the sensors. Is that device running on the SD card or the?
Yeah, so on the that answer, there's a couple different answers to that question. So on the EC2K controller, it runs its code off of NAND flash, and then for storage, for storing logs and configuration and things like that, it stores that on an SD card that's on board. For the new controller, the Edge controller, that runs completely off of eMMC.
Do you have any way of seeing the status of the AC power to, for example, the Edge controller? Know whether someone's just unplugged it.
In that
if
case,
you lose communication,
we get an offline message, so it doesn't completely answer your question. But if it's offline, it's either someone has pulled the internet connection or changed the networking rules, or they pulled the power on it. So we can't specifically see power, but we know it's either the the Ethernet connection or it's the power if we see it offline.
Did you all consider a small battery backup, like just a little lithium ion?
This would have been before my time. John might know the answer to this if it was the case. I feel like that existed at some point before my
Money.
time and doesn't exist anymore. Yeah, exactly. Bomb cost.
Yeah, I don't think a battery, other than a battery for the RTC, was ever considered for the controller.
From a security perspective, so switching all these controllers from, wires bad, move to wireless IoT, what is the plan to secure the devices so that they can't have firmware updates pushed from anyone, basically, within, because if I recall, your guys' hardware goes in physical stores, like, I don't know who any of your public customers are, but I imagine if somebody had like a flipper or a pineapple, they could wreak some havoc if they wanted, but potentially you guys have figured something out for that?
Yeah, the short answer is yes. And since this involves security, I got to make sure not to give too much away. But we have, I'll say there's an authorization dance that they do. So that's in the works there. So number one, who's pairing onto the network and who's allowed to be there. So the installation process only happens for a certain period of time while an installer is there, and then you can't really go in and change the network anymore. The other side of that is using network encryption for those types of things. And there's a really cool part, but I don't think I can really get into it, but I'll just say there's some other orchestration around security there.
Did you say the current generation is on cellular, or this will be the next generation?
Next generation is on cellular.
Who pays the cell bill on that?
So far, GridPoint, as far as I know.
Okay, interesting.
That would be a good question for Mike, but if I remember right, I'm pretty sure that that's going to get rolled up into just the subscription costs that the customers pay.
Gotcha.
No,
Well, at least you're
my
not using
burning question-
XML.
Sorry, what was that, Mike?
I was just making an XML as data hungry joke.
Oh, yeah. We're not using XML. That's good.
Okay.
Ton, did you have something?
Yeah, burning question. The microcontrollers. Do you do any over-the-air updates of the microcontrollers?
Yes.
So not the Nerves firmware, but the microcontroller firmware.
Yes, we do have the ability to do that.
And does that go through the Nerves hub? So it's like one of the commands in the Nerves hub?
So
Curious about that functionality.
No, we don't have those devices pulled into Nerves hub. Those are managed from the controller. So the control, and actually this works with our wired devices too right now. So it knows the controller knows which devices it's talking to. We have a small number of SKUs right now that controller actually needs to manage for the new platform. So right now we're able to bundle the firmware for those devices into the controller's firmware, so it has those files available. And when it's doing a handshake with those devices, it's asking, hey, what version of firmware are you on? And if it's out of date, the controller will go and update them.
Do you guys have any philosophy about when you write to disk and how often, or do you f-sync all the time or not f-sync, or any thoughts around that?
I had a philosophy going in and I have a different philosophy as of today.
Well, that's a really good answer then. I want to hear this now.
Yeah, so normally one of the things that I would recommend is try not to write to disk on an embedded device like that, except at certain times, because try not to dump all your logs to disk, right? Like that's one of the things, the philosophies behind Ring Logger is keep those logs in memory and don't wear out your disk, don't wear out your flash from writing to it. If you have an SD card, like we do in one of the units, that's a little easier because it can be it's still having somebody go out to fix this if it's a problem, but it's easier to switch an SD card when it fails, especially if it's only used for logs or temporary data or stuff like that. The new controller doesn't have, let me back up on that too. That controller also has NAND flash, and boy, does NAND flash hate being written to. It seems like it's like it just wants to corrupt itself. So like there's Linux drivers and stuff like that that are supposed to take care of it for you. But if I remember correctly, John might be able to speak more to this if I get this wrong. But NAND flash is the older technology. It's more at risk of having issues. eMMC is the newer technology that has more of that memory management type stuff built into it, and is a little more resilient to that. So we try not to write to the NAND flash portion of that unless we really have to. We're not just like dumping logs and stuff out to that portion because we don't want to wear it out. So then there's kind of a middle ground on the new controller, since that's all eMMC of, what do we do there? So my initial take is try not to write stuff. The flip side of that is when you're launching a new product, sometimes you need more visibility into what's going on in the field. Sometimes you actually need more of those logs. So one of the things that we're doing is pushing those logs up to Datadog. We're also pushing errors up to Sentry. And that's something that can help capture some of the issues. But if you have a connectivity issue or a connectivity dropout, or a hard power cycle at the wrong time or something like that, you're not necessarily going to have time to transmit those logs out, or you're not going to have the ability to transmit that out. And at those points, you do need to store something on disk, or you need to be okay with losing it. So there's an approach there where if you need it to do that early stage troubleshooting, it can make sense to turn it on. Just keep in mind what the consequences of leaving it on are. That's what I would say now.
From an onboarding perspective, so like new engineer starts, they're hired for an Elixir position. They start. Do they immediately get set up with like some hardware to play with, or like do you guys have simulators? Because I assume like if a new employee starts in middle of nowhere Canada and like they're like, oh well, I'd like some hardware to test with so that I don't have to like constantly bug a QA engineer or someone in a warehouse. Do you guys have simulation stuff for that, or how do you let developers on your teams play with hardware?
Yeah, there are several different answers to this. So I'll start from the inside out. So on the firmware team, everybody has access to a device because we need to make sure we're testing on that. Also on the QA team, every QA engineer also has access to all of the physical hardware. Once you start expanding out from there, because I mentioned there's 4 other web teams that we interface with, it varies. And so it kind of depends on a combination of like skill level plus availability of the hardware that we have as to who's able to get access to that hardware. But some of the folks on those teams do have access to that equipment. So they are actually able to run the firmware alongside of the features that they're developing. We have been kind of bad at this due to the timeline, timeline constraints we've been under. But like what I mentioned in one part of the presentation, we have had the firmware be able to run on a developer's host system, so they can spin it up without the hardware and get basic functionality going there. Due to the pace of the project, that's been in various states of working or not working along the way, depending on how fast we've had to go on certain features. But it's something that we have been doing. And then some folks on the team don't have the hardware. One of the things we've done to try to mitigate that, though, is we do have an office down in Roanoke, and there are, I believe it's 20 controllers and a couple thermostats and main load meters on the wall there. So we have a remote system as well that people can get into, and that's hooked up to the staging environment. And so they can go SSH into that hardware. It's all over VPN, so you can't get it to it from the outside world, but they go SSH into there and download their firmware onto it and test that out against staging.
What are your favorite and least favorite wireless communication technologies?
I love tech. Okay, I was about to say I love technology so much. I don't know if I really have one that I hate. They all kind of have their strengths and weaknesses, and it really depends on the right tool.
Doesn't everybody hate
job.
Zigbee? Oh, sorry, go ahead.
So I was going to say Thread for that one, but that's
Okay.
another story. We're not touching that at GridPoint, so I'll rant on that at another meetup if someone wants me to. But no, it's really about right tool for the job. Zigbee is built on top of 802.15.4. That's a really interesting standard in technology, another mesh networking technology. And nowadays you can get that in 2.4 gigahertz or 900 megahertz. So it's an interesting alternative to the LoRa space if you're looking at the sub-gig version. LoRa in this case, the range, or when you've got LoRa indoors, really the penetration ability of it between walls and stuff like that is pretty nice. LoRa point-to-point is kind of on the newer end. So LoRa WAN as a technology is very heavyweight, and you always have to talk back up through the cloud to an application server to be able to use that. Point-to-point is a lot nicer because it's more about building up a localized network, more of that Zigbee style feel to it, without Zigbee's application layer on top of it. Wi-Fi is what it is. Everyone knows how that works now. It's got its pros and cons. Cellular has its pros and cons. Really, it's the latency you're probably going to run into. Latency and cost with cellular. But for like what the Edge is using it for as a backup channel, it makes a lot of sense as a backup communication method. It's something that you can use to keep your site online there. If you're trying to send, if you were building like a controller like this and or I should say not like this, something that maybe needed to stream video down it or something like that, I should say we're using a Cat M1 cellular modem here. So that's definitely designed for the lower IoT, low bandwidth data style stuff. If you're trying to stream screenshots or video off a camera or something like that, that's not going to work for you. You need a 4G modem with more power behind it there. Yeah, I think it's all just kind of the right tool for the job in my mind.
I've been enjoying this presentation because it's always cool to hear how, things work themselves out. And I was wondering, I haven't used the processor that you've been using, but I think it's a single core, like around 500 megahertz one. So it's like it's kind of one of the slower end of what I think a lot of people tend to use. And I was wondering how things felt. Happy with it?
After John fixed Scenic with that Cairo update, it's working pretty well. And so yeah, it's a little background of what you're probably talking about. So like if you're pulling one of the official Nerve systems off the shelf, like the Raspberry Pi system or the BeagleBone system, you're operating it on a core that's a gigahertz or a little bit more. And yeah, this processor that we're using is single core, 500 megahertz. It on paper, it doesn't have a lot of horsepower behind it, but the catch is this controller is the thing that's in the middle of a bigger system. Really, its job is to shuffle data around from these devices on the edge and get it up to the cloud, and then vice versa. So it's really about passing that data around and doing transformations on that data. It doesn't have to do a whole lot that needs a really heavy processor. So it's been working pretty well for that job.
Are there any features? Is there anything with Nerves that's kind of missing for this support for that app, and specifically on system-wide area?
I mean, not that I can think of. I'm maintaining the system for that now, so it's up to date for what I've needed out of it. There's one thing, but it's probably the black sheep of the ecosystem right now. I haven't tested Bluetooth on it. It does have the Wilk 3000 module. The Wilk 3000 has been a bit of a thorn in our sides. GridPoint's not using it for Bluetooth, but I've tried to do that on other projects. That module is a little weird.
I've heard that it works, but
yeah. So I'll say this. When I was originally doing development on this system several years ago, it didn't work at the time. There were a couple horrible problems with that Wilk chip. After I updated the system and brought it back up to speed to like the 2023 platform type stuff that Microchip was releasing in their updates and brought their kernel patches in and stuff like that, that Wilk seems to be behaving a lot better, like significantly better. I just haven't tried the Bluetooth side of things and trying to get all that working since then.
Gotcha.
Yeah. So I'd say if you were to ask me for a pain point, that's what comes to the top of my mind. But yeah, I haven't had to dig into it too much recently.
No, I've heard Bluetooth more than once.
Mm-hmm.
And I've heard, I know that there's a little bit more happiness from, I believe, an NXP 8988 or something like that. I'm totally flubbing the number, but it's an NXP combo Wi-Fi Bluetooth part. But yeah, it does seem there's pain. I had another question. Are you using, so there's the Heart has a set callback. So there was like a comment earlier about, if you could brick devices, and like one of the features, one of the anti-brick features is the hardware watchdog, but you can also hook that up to reboot your system if software starts getting unhappy. And I was wondering if you all had looked into that.
Yeah, it's so there might be two answers to that question. I'm pretty sure we're using it. I can throw Abelino under the bus on that one and say if we're not using it, it's because he hasn't gotten to that ticket yet. So we do know about it. We should be using that if it's not in place yet. But as far as I know, we are. The thing that Abelino was referring to in that case is there are some settings that you can potentially mess up where if you do that, it doesn't matter how many times you reboot the device, it's gotten misconfigured, so it's not going to reconnect back up to what it's. Yeah.
So like if you delete the Wi-Fi configuration, it's going to be a brick, and that's the device is going to have trouble. Yeah.
And there's some of that stuff that's in like that factory configuration process where when you're in IEX, you can go touch that stuff. And so if you have to poke around at any of that, it's like be really careful there, because if you wipe out part of how it's provisioned, then you're in a little bit of trouble.
Slightly jokey related question, and then I'm going to read Ryan's latest question. But do you guys have a leaderboard of everyone on the team and how many devices everyone's bricked?
We've only had one or maybe two RMAs so far. So no, we don't have a leaderboard. It's been working really well. Yeah. Sweet. Yeah, no, this isn't a system that you just go in and brick. Yeah, it's been running really well. Let's see. Let me take a look at Ryan's question here. So, resourcing for customer support. Okay, so this is a great question. So, regarding resourcing for customer support, do you have a particular strategy for scaling support as the number of devices increases? This is a great Mike Ratliff question. He might have talked about this in the other presentation. The strategy is exactly the opposite of that, as crazy as this may sound. So one of the ideas behind the new platform is to be able to help reduce support costs. And there's a couple ways in doing that. And I guess without going too deep into it, because I might bore the entire technical audience with this part, is it really the philosophy behind the system is a lot more self-service. So having a mobile application that guides those installers through the process better, making the steps of what needs to happen a lot more clear, making the usability of the system a lot more clear. So like that entire dashboard has been completely revamped from the older system. So the idea there is to actually not have to have as many support people, especially when the number of devices in the field scale up. Do we make use of anything like MQTT, AMQP, NATs, other types of protocols or messaging? So in a lot of the other projects I've developed, yes. For GridPoint, no. This is a WebSocket with JSON running across it, and it was all built in-house. So the old platform used protobufs and something else that I forget. And so there was a thought around this platform. I think this was a bit before my time here. I think the thought behind that was being able to move to Phoenix channels Since we've got Elixir on the other side of that, it's easy to have the server host those channels, and we use Slipstream on the firmware side to connect up to those channels, because that's a socket library that allows us to do that, WebSocket library. And JSON's easy to serialize and deserialize, so that's what's running on top of that. And like I mentioned, this is one of the larger teams in my career that I've worked on project-wise. So we've had the resources to do that too. Some of the other projects I've worked on, especially the smaller projects or startup companies and things like that, yeah, you'll get a much faster jump start if you go grab MQTT, you grab AWS IoT Core or something like that, and don't try to build that layer yourself. You can get off the ground faster. Got another question here. So do you use the package ModBux? Yes, we do. Does it have some advantages comparing it with ModBus, the hex package? I don't know. That is a good question for, I don't think Alday was able to make it here. I don't see him in the list anymore. I was going to pass that off to him because he's the author of ModBux. What I will say instead is he has a handful of Elixir talks out there. He's done one for the Nerves Meetup. He's done a handful for Elixir Conf. I'd say I'd go check out his talks on that, because he's gone pretty in depth with ModBux in those. I'll say it's a library that we know, we've trusted. It worked well for us out of the box, so we didn't really do a big in-depth comparison between the two. We picked ModBux, it worked, and so we went with it.
One more question. The Scenic UI, is it when something goes wrong, do you have access, like controlled remotely? Like I click the button for the user?
Yeah, we don't have any type of VNC set up for that right now. That being said, we also haven't needed it yet. The users who happen to use that particular screen are the installers. So if something that goes wrong when they're on site, we'll get a phone call and we'll walk them through, whatever is happening. If something is actually happens to be wrong with the firmware, most of the time it's just they haven't understood something with the interface. It's just saying, hey, enter this here, enter that there. Actually, I don't think we've gotten any calls about the interface that I've heard of. But anyway, we walk them through that kind of stuff, and anything that we would need to change on the UI, or like any of the settings that are on there, we have access to the same settings in the console, and so we're able to remote into it over Nerves Hub, and we pull up the IEX console and we can enter whatever we need to there, and it has the same effect of hitting the buttons on the screen. We're just doing it from the command line.
In case of your device connects to the field or customer's network, do they give you access, like open up the port, or how does that resolve?
Yeah, we have a pre-installation process where they receive a document that says here's all the ports that it's actually, they don't have to open ports coming in. They need to allow access out to a couple domains out on the web that we have. So we say allow access to this domain and this domain and this domain, and as long as they allow that, then our controller can go connect up. Frank writes he thinks Boyd has a way to do Scenic remotely. Yes, he does. I know he showed that off. I don't know if it ever went public, but yes, you can do Scenic remotely. We're just not doing it. Well, thanks for showing up tonight, everybody. This was great. Thank you very much for the questions as well.